let's do some questions. So the first question is about a vector A which is making some angle 20 degree and there is a vector which is making 110 degree, and both these angles are made by the x-axis. So from x-axis these angles are given. Now the magnitudes of these vectors are also given 3 and 4. So we need to find the resultant of these two vectors. So first question, so let's first try to draw the diagram. So let's say we have two axes, x and y axis. So let's say this is our x axis and this is our y axis. So it is given that the angle that A is making is 20 degree with the x axis. So let's say this is approximately 20 degree and B is making approximately 110 degrees. So this is approximately 110 degrees. This is vector B. So we have to find the resultant. So the resultant of this two will be in this particular direction, like this approximately. So how to find it mathematically? So we have been given that the magnitude of A vector is 3 and magnitude of B vector is 4. So the resultant magnitude will be, according to our formula, A square plus B square plus 2AB cos theta. Now the important thing is, what is theta here? So theta is the angle between the two vectors. So the angle will be, if you apply some logic, you will understand that the angle between them will be 90 degree. Okay, this angle will be 90 degree. This is quite simple. This is 110, this is 20. So when you subtract them, you will get 90 degree. So root 3 square is 9, 4 square is 16 plus 2 into 3 into 4 into cos 90 is 0. Cos 90 is 0. So you will have root 25. So r will be equal to 5 meters. So the resultant will be 5 meter. Now what about the angle? So this is the value, magnitude. Okay, now what about the direction? What about the angle? So the angle, let's say beta, okay, between resultant and A, angle between resultant vector, that is R, and A will be tan inverse beta equal to tan inverse. Now the sine theta, and the B vector will be here, magnitude of B vector upon A vector plus magnitude of B vector into cos theta. This is the formula that we have. So tan inverse 4 sin 90 upon 3 plus 4 cos 90. So once you solve this, you will get beta equal to tan inverse 4 by 3, and once you solve this, you will get 53 degree. You will need a calculator for solving this usually. So after solving this, you will get 53 degree. So we have both angle, that is the direction, and the magnitude. Now if this 53 degree is there from A, so what will be the angle made by this resultant with the x-axis? So it will be, this angle is 50, okay, this angle is 50. So this whole angle will be 50 plus 20, that is 70 degree. So angle with x-axis will be equal to 73 degree. This is 53. This is 53. So this is the solution of first question. In the second one, again we have two vectors having same magnitude, which is 10. Now one is and they are inclined with x-axis at angle 30 degree and 60 degrees, that respectively, that is A is inclined at 30 degree and B is inclined at 60 degree. So we have to find the resultant. So the solution for the question number 2. So let's first write the magnitude which is given. Magnitude is same for both the vectors, 10 units. 10 units mean it can be 10 centimeter, 10 meter, anything. Then the angle between the two vectors will be 60 degree minus 30 degree, that is 30 degree. So what will be the resultant magnitude? 10 square plus 10 square plus 2 into 10 into 10 into cos 30 degree, just like the above question. So after solving this you will get 19.3 units. Resultant will be 19.3 units. Now what about the angle beta? So let's say angle between resultant and vector A so let's say the angle is beta, it will be tan inverse. Just like the above formula, we will have 10 sin 30 degree upon 10 plus 10 cos 30 degree. So after solving this, what we will get? We will get tan inverse 0.26795 approx. So after solving this using a calculator, you will find that it is equal to approximately 15 degrees. So the angle between resultant and A will be 15 degree. Now angle between resultant and x-axis will be 15 degree plus 30 degree, that is 45 degree. Okay, because the angle between A and x-axis is 30 degree. It is just like the first question. Now in question number 3 we have 3 vectors. Now we have to add these 3 vectors A, B and C. Their magnitude is 100, all 3 has the magnitude 100 and they are inclined at different angles with the x-axis. So let's try to solve this question. Solution for question number 3. So let's first let me draw the diagram, x-axis and y-axis. So one of the vector is like this, having angle 45 degree. One of the vector is like this, having angle 135 degree, and one of the vector is approximately like this. So this whole angle is 315 degrees. So this is the diagram that we will have. Now here we need to add this 3 vectors. So what we can do is we can make the components individually, x and y components, and then we can add x components and y components individually. So first let's try to find the x components of all the vectors. So for vector A, it will be 100 cos 45 degree. Let me tell you how. So this is x-axis, this is y-axis, and this is 45 degree. This is vector A. So this will be A cos theta, that is A cos 45, and this will be A sin 45, as we have discussed in the other lectures. So because of that, the x component will be A cos 45 degree. Similarly for B component, B vector, the x component will be 100 cos 135 degree, which will be, this is 100 upon root 2, this is 100 upon root 2 as well. Now for C component, it will be 100 cos 315 degree, which will again give us 100 upon root 2. Similarly, let's try to find the y component. So y component for A vector will be equal to 100 sin 45 degree. Again look here, y component, a sin 45, that is 100 sin 45, b vector 100 sin 135, c vector 100 sin 315 degree. So they will give us 100 by root 2, 100 by root 2 and minus 100 by root 2. Okay, the values of different angles. So now what will be the resultant in the x-axis? Resultant x component will be, we need to add all this, so will be equal to 100 root 2, then this is actually minus 100 upon root 2 plus 100 upon root 2, so this will give us 100 upon root 2 as the answer. And similarly resultant y component will be equal to, add all this, 100 upon root 2 plus 100 upon root 2 and minus 100 upon root 2, this will give us 100 upon root 2 again. So the resultant will be root x square plus y square plus 2xy cos theta. Now we know that theta will be 90 degree for x and y. Okay, see here, x and y are perpendicular to each other, so 90 degree. So this component will be 0, cos 90 is 0. So ultimately what we will have, 100 upon root 2 square plus 100 upon root 2 whole square. So after solving, what you will get is 100. So the resultant vector will be 100. Magnitude of resultant vector will be 100 units. Now what about the direction? So it is quite simple. The angle between the two components, y component upon x component, will be our angle. So we know that both these components are same, 100 upon root 2, 100 upon root 2, which will give us 1. So alpha is equal to tan inverse 1. So this will give us 45 degree. So resultant is 100 and the direction angle is 45 degree with x, even with y, any angle, any axis same is there. So with x axis 45 degree. So it is something like this, x, y. So 100 and angle is 45 degree. This is the resultant of the three vectors. Now in the fourth question we have been given the unit vectors. The terms are in the form of unit vectors. So I represent x, j represent y and k represent the z. So here we have two dimensions, x and y. So we have to find the magnitudes of a, b, a plus b and a minus b. So question number 4 solution. So we have been given a vector is 4i cap plus 3j cap and b vector is 3i cap plus 4j cap. So these are the quantities that are given. So first we need to find the magnitude of a vector, which is quite simple, just square the individual components. So we will get 5. For b vector again, just square the individual components, 3 square plus 4 square, which will again give us 5. Now see, here we are asked about the magnitude of a plus b. So how to find the magnitude of a plus b? So before we do that, let me tell you what will be a plus b. So a vector plus b vector will be 4i plus 3j plus 3i plus 4j. So how to find the addition? Just add them, I component to I and j component to j. So it will be 7i plus 7j. So ultimately it will be 7 square plus 7 square, which will give us 7 root 2. And again a minus b, it will be equal to, so once you do this a minus b, so what we will have 4i plus 3j minus 3i plus 4j. So it will give us 1i minus 1j. Okay, 1i minus 1j. So it will be 1 square plus minus 1 square, that is root 2. So these are the values: 5, 5, 7 root 2 and only root 2. So this is our question number 4. Now question 5 is a bit long. In this question we have been given 3 vectors a, b and OA, BC and DE. These 3 vectors are there having different angles from the x-axis in different orientations. Remember, okay, they are in different angles are given from different orientations, so just keep that in mind also. So we have to find many things like the magnitude and x and y components. So let's try to solve this question. So question 5 is there. So first of all, let's try to draw the diagram that is given. So let's say this is the y-axis, this is the x-axis. Now from the origin, one is vector is a, angle 30 degree, and from some other point we have a vector E which is having 90 degree, so DE vector. And then we have another vector like this, this is 60 degree from this side, so this is important. What will be this? This will be 120. Okay, and one more thing, this is 90 degree from this side, so what we will have? We will have 270 degree from this side, from x-axis in the clockwise direction. Okay, sorry, in the anti-clockwise direction. So remember that all the angles will be taken in the anti-clockwise direction. The units, the magnitudes is 2 meter, 1 meter and 1.5 meter. So this is given. This is BC, by the way, and this is OA. So we will find individual components. So first let's try with x components. So for OA vector, this will be 2 cos 30 degree root 3. For BC, this will be 1.5 cos 120. Again remember, why 120? This is 30, this is 120, remember, and for this we will use 270, remember this thing. So it will give you minus 0.75. And for DE, 1 cos 270, okay, remember 270, so 0. Similarly for y components, for OA vector, 2 sin 30 degree, BC 1.5 sin 120, DE 1 sin 270 degree. This is 1, this is 1.3 and this is minus 1. So resultant x component will be root 3 minus 0.75 plus 0. After solving you will get 0.98 units. And y component, 1 plus 1.3 minus 1, that is 1.3 units. So resultant r will be root rx square plus ry square, and plus 2 rx ry cos 90 degree will be there, so it will be 0. So ultimately what we will get after solving, putting the value 0.98 square, 1.3 square, so solving this you will get 1.6 meters, 1.6 meters, and obviously the angle tan inverse y component upon x component. So after solving this, you will get tan inverse 1.32. Tan inverse 1.32. So this will be the angle. Resultant and angle. You can further solve this also if you want to. You can find the angle in degrees. Now in the sixth question, we have two vectors having magnitude 3 and 4. So we have to find the angle between them if resultant is 1 or 5 or 7. So here resultant is given in the question itself. So let's try to write the given quantities first. So A is 3, B is 4. So the first part is, what if the resultant is 1? So this is quite simple. 1 equal to root 3 square plus 4 square plus 2 into 3 into 4 into cos theta. We have to find theta here. So after simplifying this, you will find that theta is equal to 180 degree. Similarly, in second case, the resultant is 5. So 5 equal to same procedure, cos theta. So after solving this, you will get theta equal to 90 degree. And third situation is resultant is 7. So 7 equal to same thing, 3 square plus 4 square So in this case, theta will be equal to 0 degree. So this is quite simple. You can straightforward find this angle using the basic formula of resultant of a vector. So in order to understand this question, we will draw a diagram. By that you can easily understand what they are asking. So we have a spy report about a suspected car. So that car has moved 2 km towards east, then left turn is there, then 500 meter from in that direction, then again a perpendicular right turn, and then 4 km. So let's try to solve this. We have to find the displacement of the car. So seventh one. So let's try to draw the diagram. So first of all, let's say we are here, okay, and it moves like this, A to B. So towards east, A to B, okay, 2 meter. How much? 2 meter. Then what, it takes a perpendicular turn towards north like this, C. Then again a perpendicular turn like this, okay, towards D. So by the way, this is 4 meter, this is 0.5 meter. So this is the situation that we have. So the final point, the initial point, so we have to find the resultant, okay. Resultant is that. So how can we find the resultant? We can find the resultant by drawing this particular diagram. So this much is 2, this much is 4, and this is 0.5. So this is total 6 meter, and this is 0.5 meter. So hopefully now you can easily solve this question. So eddy vector is 2i cap plus 0.5 j cap plus 4k cap. You can also write it like this. K is 0 actually. This k is 0, but let's remove this, and we have 4i, okay. 2i because x direction, this is 4i because again x direction, and this is 0.5 j because in y direction. So we will get this thing. So the resultant will be 36 plus 0.5 square. 6 square is 36, remember. So once you solve this, you will get 6.02 units. Okay, whatever the units are, kilometer, meter, whatever the units are. And then angle tan theta will be d by AE. Theta will be tan inverse d by AE. So theta tan inverse will be 1 by 12 once you solve this. So this will be the angle in which it is moving. So angle and the magnitude. Now in question number 8. So again this will be more clear once I draw the diagram. So here we have a carom board and on it the size of the carom board is, by the way, 4 cross 4. Okay, 16 square feet. Okay, 4 into 4. It has the queen at the center. So queen is positioned at the center. So then it is hit by a striker and it moves like moves towards some edge, then rebounds and goes in the hole. So there is some complicated trajectory going on here. So we have to find the displacement. Okay, how much displacement is there for the queen, and the displacement has to be founded from different initial points like center or from the front edge of the hole, etc. So let's try to understand using the diagram. So we will assume a few things. So let's say first of all this is our carom board, approximately a square. Let me try to draw a perfect square here. Now this is the center. Okay, now the queen is here. So let's say that let's say this is point A, this is point G, this is point E. Now let's say the queen moves like this. Okay, let's say the queen moves like here and here. So it goes, rebounds from here and goes into the hole. Okay. Let's say this point is C point, and let's say we have a point here, B point. Now let's take this point to be B, straight like this point to be B. So you can easily see that BC will be equal to 2 feet, because this is half is 2 feet and this is again half, 2 feet. So this is that. Then let's say this is F point. So A to F is again 2 feet. This much distance is 2 feet. Okay. Now let's assume that the distance between A and B is x, and so this distance will be 2 minus x, because the complete distance is 2. So this is x and this is 2 minus x. So now you can understand why we are doing all these things. So DE is 2 minus x. This is D, by the way. This is D. So now let's try to solve this question. So first of all, let's take triangle ABC. So in triangle ABC, tan theta is equal to x by 2, and in triangle DCE, tan theta is 2 minus x by 4. This is by perpendicular upon base formula. Now ultimately this 2 will be equal. This 2 will be equal. Look, this angle theta. No, the angle is actually one angle is this and one angle is this, and this angle theta. Now these angles will be approximately equal, so x by 2 equal to 2 minus x by 4. So from here we will get 6x equal to 4, so x will be equal to 2 by 3 feet. So we have got x. So first of all, if we want from the center, then AC will be the thing that we need to find. So it will be AB square plus BC square, which will be 2 by 3 root 10 feet. And if from the rebound point, then D will be the distance. So it will be 1 minus 2 by 3, that is 4 by 3 feet. So CD will be 4 feet. And because of that, C will be root CD square plus D square equal to, after solving, 4 by 3 root 10 feet. So from rebound point, from the center point. And another situation, now we have to take AGE. So we have to find from the center the direct location, direct hole. So AE, we have to find AE. So root AG square plus GE square. So this will give us 2 root 2 feet. So these are various displacements from various different positions. So let's try to again revise what we have done. So let's say the striker was here, it went here, then here. Okay, so this is our situation. Let's say this is 2 feet, this is 2 feet, this is 2 feet, this hole is 4 feet. Now let's take this to be x, so this particular distance will be 2 minus x. If this is x, then this will be 2 minus x, because hole is 2. Now first situation was to find the displacement from the center, so we had to find AC, displacement from center and the position of rebound, so AC. So AC was found out by this. Second was that from the rebound to the point of hole, so that came out to be, CE came out to be this much. And last was directly from center to hole, this one AE. So AE came out to be this much.